Okay, we actually did this problem, I'm going to say a long time ago, and we found out that this actually equals 0. There's a link in the um, the work to go through that, by the way. Let me tell you where that is. Right over here. Whoops. It says you've been noted that we've already done this integration, and it's problem 16 on page 176. At least at the time of writing of this document. Those numbers could change over time, by the way, because documents do get updated. So what I want to do is, kind of go through the problem, and it's related to this basal identity, and we're just going to go through it. All right. And certainly everything's written up for you. And what I did was I kind of took this integration here, which I noticed is a real number 0, and I started to write down it in complex form. All right. So what I want to claim over here is that we're doing something, and what we're doing is we're taking these identities that we know about, and this one over here. Now, certainly the one that you know about, that at least you should know about, is e to the ix equals cosine of x plus I sine of x. And you should now know that e to the minus ix is going to be cosine to the minus x plus I sine to the minus x. And this simplifies even odd identities to cosine of x minus I sine of x. All right? And what I do is I add those two together. So if you do e to the ix plus e to the minus ix, what would you get? Well, you just get 2 cosine x. All right? So I'm going to say, I understand that part right over here. I understand where that's coming from. The next thing I did was I factored out e to the ix on that. All right? So if you do that, e to the ix, you factor it out, what do you get? 1 plus e to the minus 2ix. And that's where this thing is coming from right over here. All right? The next thing I do was I used the rules of log to split it into 2 integrations. So this is, one integration I'd write down. I'm splitting that log problem into 2, and I get this one over here. All right, so I'm at a place where I could actually do one of the integrations. Let me start to erase all this business over here. And we'll concentrate on one integration at a time now. The integration I want to concentrate on is this one right over here. And that's a very easy integral to do, by the way. So the natural log of e to the ix is just simply ix. And if you're integrating that, that's pretty simple, by the way. That's going to be I, some number, x squared over 2. Limits of integration go from 0 to pi over 2. What would you get there? You get I, pi squared, and then squared 2 before, and 4 times 2 is 8. So you get, something pretty simple. You get this over here, all right? However, we're left with a problem, and we're left with this problem over here. We're left with this, and this is a problem now. So I'm going to claim I got part of it done, but I don't know the other part, all right? And so what I'm going to do over here is just remind you that it's something to do related to the geometric series, all right? Let me get my eraser out. And again, I want to point out we're working on trouble now. We're working on this piece of trouble here. Before I get to that piece of trouble, geometric series, we got this over here. I integrate both sides. Well, integration, this left side is pretty easy. Integrating the right side, also fairly easy. You get this over here. Fairly easy, by the way. Figuring out the c, pretty easy. What do? Set u to be 0, and you would get this over here. All right? And we notice convergence for this over here. All right? So, the next thing I do is I just simply change the letter in the problem, this over here. All right, and the reason for the z is a complex number now. And I just kind of write it down, and I plug it in. Right? So what am I doing over here? I'm doing this business over here. Whoops. I'm doing this business over here. All right? Just plug it in. And wherever I see the z, I just plug in e to the minus 2ix. But I didn't bother doing the multiplication. I just said, times 3, times 4, yada, yada, yada. All right? Not so bad. All right? So before I go on, I want to just remind you that, my integration, it produced 0 when I did it, way back on page 176, problem 16. So the a and b are both 0. So the complex part, the complex number is a combination of a real part, an imaginary part, and both a and b are 0 in the problem. But I still have trouble over here. And the trouble is trying to do that integration now. And someone says, what integration are you talking about? This one over here. All right? And it's trouble. There's no doubt about it. So what I want to do is write it down. All right? So we know this produces this, and I'm still left with this nightmare integration to do. And what do? I write it down. This is easy. This isn't so bad to write down. I just, write down what I wrote down before. I know the natural log is going to be equal to that under some conversion interval. And then I can integrate that, term by term. It's fairly easy to do, by the way. By the way, when I do that, I want to point out what I mean by integrating term by term. They're fairly easy to do. What are you going to get? Well, the first term is going to be e to the minus 2ix. I got to divide through by minus 2i. Right? If I did the next one, what would I get? Well, I don't want to do every one because it's infinite. It would be e to the minus 2i x times 2. What would I get over there? I would get minus 2i. Well, there's already a 2 there, so it's going to be 2 squared now. And I started to realize you get a really, kind of a simple pattern over here. All right? What I did, though, was I factored out the minus 2i. Well, that's over here now. All right? I got that part covered. Now, of course, it's an evaluation problem now. I got the evaluation top and bottom. All right? Now, my suspicion is, one's going to be pretty easy to do, by the way. And I'm going to say the bottom limit's easy to do. That's the first thing I would do. And what am I doing? Wherever I see x, I put 0. And what are you going to get? Well, that bottom limit, right? You're just really getting something pretty simple. You're getting 1 over 2i. And then you get 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, yada, yada, yada. So that's the bottom limit, all right? By the way, we're subtracted later, by the way. Maybe I should just erase that because it doesn't look like I'm doing that. All right, I got to do the upper limit, though. And the upper limit is more challenge for me. All right, let me erase this over here. And we're going to move on to the upper limit. The upper limit's pi over 2. And what you probably should know, or at least retain, is that e to the I pi is actually equal to minus 1. All right? And that's an interesting fact, by the way. And so what I'm going to do is I'm just going to evaluate the upper limit. And as I do that, I get the 1 over 2i. That's certainly true. And then I kind of plug this in. And, I notice every single time I'm getting something. And what am I getting? I'm getting e. Whoops, sorry about that. If I plug in the pi over 2, I'm always going to get this e to the I pi. I know it's minus, by the way. All right? And then what over here? You start getting times 1, times 2, times 3, times 4, blah, 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 blah. So, I'm looking at it. It's going to be this minus 1, but it's kind of going back and forth. All right? So, the first term, fairly simple. You just get this. Now, the next term, it's going to be minus 1. By the way, let me clarify that. I realize I got e to the I pi is equal to minus 1. I hope you realize that e to the minus I pi is still going to be minus 1. All right, raising both sides to the minus 1 power. All right, but I got this thing going back and forth. All right, now what I mean by that, the second guy is going to be a square of that, so it's going to be plus now. I see that. The next guy is going to be cube of the minus 1, so I see the minus, and it goes back and forth, back and forth, back and forth, back and forth. What do I have over here? I have upper minus the lower, upper minus the lower. And that's what I want to do, upper minus the lower. All right, certainly we get 1 over 2i. Upper minus the lower. What do you get there? Well, let's take a look at that. Boy, a lot of things disappear, don't they? But what are you going to get over here? You're going to get minus 2 over 1 squared, right? Upper minus lower, upper minus lower. That disappears. Then what do you get? Minus 2 over 3 squared. And then you get minus 2 over 5 squared minus yada, yada, yada. All right? Now, certainly looking at it, the one thing I want to do is I want to factor out the minus 2 now. All right, so if I do that, what would you get? You would get minus 2 over 2i, and then you would get 1 over 1 squared plus 1 over 3 squared plus 1 over 5 squared plus yada, yada, yada. Let's figure this out, though. All right, I'll put that aside. So it's going to be minus 1 over I. I'm going to, multiply top and bottom by I. What do you get there? Minus 1 times I on top and I squared on bottom. And I squared is going to be minus 1, so you just get I. All right, that's pretty remarkable. And let's make sure you understand where that's written right over here. All right, and then we get this business over here. So what do we do now? We write it down. So what are we writing down? We're writing down what we know. We got the integration. I had this, I have this, and now I've got this part over here. All right, and it's an infinite sum, by the way. What am I noticing about that, though? And that looks like it's going to be a number, but what do I know about this integration? The integration here produces 0 plus 0i. So what does it really mean? It means that this thing over here better sum to 0. All right? Now, if that's going to sum to 0, what am I basically saying? I'm basically saying that pi squared over 8, whoops. Let me go backwards a little bit. I'm basically saying that pi squared over 8 would have to be equal to this thing over here. All right? Now, that's an interesting identity, by the way. All right, now you can certainly announce this as being what our goal was, but that's not our goal. Someone says, what was your goal? Our goal was to find out that basal identity. All right? So the way I'm going to do that is I'm going to insert the missing places. And for this to be the basal identity, what I have to do is insert an infinite number of terms. And it would be like, I'd have to insert this, I'd have to insert this, I'd have to insert this, so forth and so on. So once I do that, I'm starting to realize, I'm getting what I want. And I want to point out, this is what I want. I want, basically that basal identity. I want this over here. I'm going to put j down. J equals 1 off to infinity, 1 over j squared. I do want that. All right. Now when I look on the other side, I'm looking at this thing over here, and this looks really strange to me. So, what I'm looking at is I'm kind of looking at something there that just doesn't look right. And what I'm going to do is I notice that each bottom actually contains a 2 squared in it. For example, the first one, I could write down 2 squared, 1 squared. That's over 1. The next one I could write down as 1 over 2 squared, 2 squared. The next one I could write down 1 over 2 squared, 3 squared, so forth and so on. So I factor out the 2 squared in the bottom, and that's written right over here. All right? And then I get this business over here, which again is this thing over here. All right? So what do I do over there? I'm going to say that this is really one of these things, and this is going to be 1/4, and I subtract it from both sides. And what do I get over here? I get this. I get pi squared over 8. Again, I want to repeat this over here. We're subtracting this from both sides. We're subtracting it from both sides. What do you get? Well, 1 minus 1/4 is 3/4. So I'm getting this over here. All right? And then what do? I multiply both sides by 4/3. Let me put what I mean by that. So it's going to be pi squared over 8 times 4/3. What happens here? 4 goes into 4 once, goes into 8 twice. You're going to get pi squared over 6. I'm at my point I want, which is the basal identity. We got it right over here. Was this a lot of work to get there? It was a lot of work to get there. All right? And by the way, what I mean by a lot of work, maybe we glossed over some issues over here, but we went through a lot of work to get there. All right? So we just showed the basal identity, and it was a lot of work to get there. All right? So we're done. Thank you.